Good morning, children. So let's discuss about the theorem 5.1. So theorem 5.1, it is given that two distinct lines cannot have more than one point in common. That means if any two lines are there, so these two lines will not intersect in more than one point. So this is, suppose this is a point of intersection and this is the line L, this is the line M. So these will not intersect in more than one point, as we already know. So here we are given two lines, suppose L and M, as we have already drawn. These are the two lines, that is L and M. So let us suppose that the two lines intersect in two different points. So suppose when in the proof, so let us suppose these two lines intersect in more than 2 points other than O. So again some other point is there where these two lines will intersect. So from there we can conclude that these two lines intersect at two different points. So you have two lines passing through two distinct points P and Q. Suppose if one point is P and the other point where these two lines intersect, it is Q. So therefore the two lines will pass through these 2 points P and Q. But this is a contradiction, as we already know according to the axiom 5.1 that given two distinct points there is a unique line that passes through them. So if 2 points are given, so there is only a single unique line which passes through them. We can draw only a single line through any two given points. But here in our assumptions we have assumed that the two lines passes through two different points, that given two different points, that is P and Q, two lines passes through them. So this is a contradiction. So the assumption that we started with, that the two lines can pass through two distinct points, is wrong. So therefore our assumption is wrong. So hence we can conclude that we are forced to conclude that the two distinct lines cannot have more than one point in common. So therefore the two distinct lines cannot have more than one point in common. That means they will intersect only at a single point. So given any two lines, they will intersect only at a single point. So equivalent versions of Euclid's fifth postulates. So here we will discuss about the equivalent versions of Euclid's fifth postulate. So let us recall the fifth postulate. What the fifth postulate states. So if a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than two right angles. That means two lines are given, two lines, again another line is there. So suppose this is the line L, this is the M, and this is the N. So these two lines and these are the interior angles. So these two lines will intersect on that side. So these two lines will intersect on that side where the sum of the interior angles on the same side is less than 180 degree. So suppose this is one angle, this is angle 2. So here the sum of the angle, that is angle 1 plus angle 2, must be less than 180 degree. So hence these two lines will intersect on this side. So these two lines will intersect on that side where the sum of the interior angle is less than 180 degree. So this is the fifth postulate that is being given by Euclid. So now some equivalent version of these fifth postulates were there. So one of the most famous or widely used equivalent postulate of this Euclid's version is given by the famous Scottish mathematician John Playfair. So it is given by the famous Scottish mathematician John Playfair in 1729, as you can see in the picture. So he stated that for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. For every line L, so if there is a line L, so this is the line L, and for every point P, so P is a point which is not lying on L, so there exists another unique line, so unique line M which passes through P and it will be parallel to L. So that is the equivalent versions of Euclid's postulates, and it is given by John Playfair in 1729. So again, from this we can conclude that two distinct intersecting lines cannot be parallel to the same line. Two distinct intersecting lines, if these are the intersecting lines, suppose one is L, one is M, it is intersecting an O, so this at the same time both of them cannot be parallel to a third line. Suppose this is N, both of them cannot be parallel at the same time to another third line. Okay, so it is given that two distinct intersecting lines cannot be parallel to the same line. So that's all for today. The remaining we'll discuss in the next class. Thank you.